Welcome back to yet another video and another one on this very chapter we are looking at. So in the last video we actually discussed about another form of integration, which is how do we integrate a product. Okay, and then we saw this form where we said if we integrate this, if we differentiate this, if we are getting this, our result is going to be we increasing this power by 1 dividing by the power we have, which is the new power. We also treated a lot of examples in the last video, so if you have not watched that, I think you should just go to this playlist and try to watch that video before you come to this, because in this we are going to build on what we did in the last, or what we discussed in the last video. So we'll look at some more examples. So I have this. If I differentiate what I have in this bracket now, x squared plus 2, what I'm going to get is 2x. So you can see the result I'm getting is not actually what is outside. They are not the same thing. Okay, so when they are not the same thing, what can we do? In this case, something can be done. It's not in all cases that something can be done, but in this case, something can be done, because our result we are getting is 2x. Is a linear function. What we have here is also a linear function, 8x. Okay, and it's in the form where 1 is a constant multiple of the other. So when 1 is a constant multiple, when the result you have and what you expect, 1 is a constant multiple of the other, something can be done. So in this case, we can actually factor out 4 from this. Okay, because if I factor out 4, what I'm going to be having left should be 2x, which is what I expect. So I'm going to factor out 4 from this. So when you factor out 4, you're going to get something that looks like this. Factored out 4, I have 2x into still what I have here, x squared plus 2 raised to the power of 3. Now if I differentiate this, I'm going to get this. And we know the result for this as a whole, it is what we've been working with, is going to be x squared plus 2 all raised to the power of 4 over 4. Then coupled with this 4 we have here, we are now going to get the result that looks. So this 4 is this one we have here. When we integrate everything we have here, this becomes our result. So from this part down to this part becomes the result to this. Okay, so now 4 and 4 can cancel. When they cancel out, so when 4, you can see these 2 can cancel out. Once they cancel out, what you have as your result becomes x squared plus 2 raised to the power of 4 plus c. Simple enough, right? So we have another example. This time around, this is what I have. Okay, so from what I have here, you see if you differentiate what you have in this bracket, if you differentiate what you have here, what you're going to get to be 8x. I think so. That's 8x raised to the power of 3, correct? Plus 4. This is what you're going to get. And what you have here is not 8x raised to the power of 3 plus 4. What you have here is 16x raised to the power of 3 plus 4. So the difference between these two is actually a factor. Difference between these two is a factor. And you can guess what the factor is. Difference between these two is a factor of 2. If I multiply this by 2, this is 8x actually. If I multiply this by 2, I'm going to get this. So for the fact that the difference is a factor, I could go ahead and factor out 2 out of this. Factoring out 2, and I have 8x cubed plus 3. Okay, so now if you see, if we differentiate this, our result is going to give us this. For that reason, everything here, we know the result, which is something simple, something we'll be working with. So the result of this is known already. So what we just have is, what is this 2? The 2 is just going to be in front of here. So this is the result we have. 2x raised to the power of 4 plus 2 raised to the power of 4 all over 4. Because we're increasing the power by 1. From 3 the power becomes 4. Now this 2 can cancel out. Okay? This can cancel out this to give us 2. So if that is giving us 2, the result is now going to be 2x raised to the power of 4 plus 2 all raised to the power of 4 divided by 2, and that is your result. So we have one last example to treat here. This time around, if I have this, now if I differentiate what I have in this bracket, okay, if I differentiate this, what I'm going to get to be 4x. So you notice that this is 4x, what I have here is 2x. They fall in the same class, but they are not actually the same thing. Okay, they are both linear function. One is a multiple of the other. If I multiply this by 4, I'm going by 2 rather, I'm going to get this. Okay, so in this case, unlike the other ones where we had to factor out something from this, here we can't factor out something from this. Actually you could, but let's not do that. So what we want to do here is to multiply this so that we are going to get 4x. So what can we multiply 2x by to get 4x? You guess it right, we can multiply this by 2. Once we multiply this by 2, we are going to get 4x. But now this is mathematics. You can't just bring 2 from somewhere, just bring a number from anywhere and then multiply an expression you have. If you multiply, it means you've altered the meaning of that term. So we can just multiply by 2, because once we multiply by 2, we've altered something. It's more like you having 100, and then you just multiply 100 by 2, you have 200. You've altered it. 100 and 200 are not the same thing. Okay, the only time it could be the same is when you multiply 100 by 2 and you still divide it by 2. So it's as if you're multiplying it by 2, you have 200. Then you still divide by 2, which is still going to bring you back to 100. It's awkward. It looks somehow. Why would someone actually try to multiply by 2 and still divide by 2? Or I will multiply a number by 100 or by 10 and still go ahead and divide by 10 just to get back the original number. But it's something we do a lot in mathematics, and that's what we are going to do here because we want to achieve something. So here we are going to multiply by 2. If I multiply this by 2, I will get 4x, but I'm still going to divide by 2. So multiplying by 2, I have 4x. Dividing by 2, this is me dividing by 2. Okay, once you have 1 over 2 here, it means you're dividing by 2. Please take note, division is same thing as multiplication to some extent. If you're dividing a number by 7, then it means you're multiplying that number by 1 over 7. You're dividing a number by 10, then it means you're multiplying that number by 1 over 10. Okay, so me, I want to divide this number by 2, so that's why I'm multiplying by 1 over 2. So it looks as though I'm dividing by 2. So if you notice, 2 and 4 can still cancel to still give you back 2, which still boils back to the original term you have here, looking as though you've done nothing. And that is what we want to achieve. Sorry about that. So that's what we want to achieve, to have an expression that looks as though we've done nothing. We have original term. Okay, so now what we have here, we already know the result to this. We know that the result to this is something we can achieve since we already know the form. So we are going to increase the power by 1, which will give us minus 5. We divide by still minus 5. We have this 1 over 2 in front. Now these 2 and minus 2 will cancel to give us minus 10, and minus 5 will give us minus 10. I can bring the minus sign outside to get minus, then I have 10 here, and this is what I have. So you can still take it a step further so that this expression raised to the power of minus 5 can come below and then it becomes the power of 5. That's something I'm going to leave for you to work on. Okay, so that's what we have in this video. Hopefully you enjoyed the video and you learned 1 or 2 from it. Go ahead and ask questions, subscribe to my channel, comment, and just do something nice. Okay, so I'll see you guys in the next video where we are going to be looking at something else. We are done with these 2 basic forms of integration, the one of division and the one of multiplication. So in the next video, to be precise, I'm going to be considering definite integral. We are going to be looking at definite integral. Thereafter, then we'll go into some other techniques of integration by partial fraction, by parts, by substitution. I think we are going to start with integration by substitution before going into partial fraction and integration by part, and then we'll go into some other advanced integration. Okay, I'll see you guys in the next video. Bye bye.